My next speaker is a managing director at Mateo Incorporated. I've known Mateo for quite some years, so I'd like to, and he's also an evangelist who's been speaking on augmented reality for a number of years. Please welcome Roman Hasenbreck.
Thanks, Brian. Yeah, I'm super excited to be here today because capturing and compute solves two very important issues for augmented reality, and I will come to that later on. So I'm talking about unboxing history with augmented reality today. Mateo, as a company, we are more focused on the creation. So if you think about the three focus points of the conference, we are really more in the creation space, but capturing and compute ties very much into what we are actually doing. Before I come to the example that we have prepared for you today, I would like to give you a quick intro to the company and then walk you through more advanced technology that we're working on at the moment to give you a good idea where the market is currently and the technology. And then I come back to the actual topic of the presentation, which is unboxing history. So Mateo has been in the market for about 12 years. We were founded in 2003. And if you haven't heard about us, we actually have a very strong focus on computer vision. We employ a whole number of researchers, and we are very much involved in all kind of research topics, and that's also how we got in touch with Brian a number of years ago. We provide the result of all this work that goes into our R&D is our Mateo SDK, which is currently one of the, if not the most advanced SDK out there for augmented reality. And it attracted an ecosystem of about 130,000 developers that we have on our platform. Okay, so what you see here right now is basically the advancement from 2D tracking. A lot of you might have seen technology that allows you to basically recognize a plane marker or an image, or you might have played with an application that tracks a page in a magazine. This is basically the evolution of that. So it allows us, by virtue of using a line edge model, to recognize and track objects, and this technology is called hybrid tracking. You're one of the first to see this, actually, because it is a very intelligent mechanism that jumps back and forth between what is called object tracking and point cloud tracking, depending on what is better in the current circumstance. And this can be used, for instance, we have one example where we track we use the sugar factory. I don't know if you heard about the massive construction. I don't know if they've already started in New York or if that is still in the planning. But what we did is we tracked the building and we superimposed how the new buildings will actually look like. And we used the technology for that. So this is on a very small scale. It also works on a larger scale and solves a lot of problems for us. The second example I would like to show you is in an unknown environment. So this is basically when we start tracking and the experience from a known object, from something that we can pre-teach. But sometimes there's a need to basically start from in an unknown environment. And then we use a technology that is called SLAM. So what you see here is a virtual chair that we place in a room, and we're actually using an RGBD sensor for that. And you might not have noticed that, but this was actually a super cool and advanced demo. It looks kind of boring, so I walk you through what is actually happening. By using the depth sensor, we are able to reconstruct the environment in real time, and that allows us to solve what is called the occlusion problem. So we can actually place a virtual piece of furniture or a virtual object behind a real object. So we're reconstructing the environment in real time, rather rudimentary. It's not good enough to use it then for 3D tracking, so we call that an occlusion model that we create in real time here. And this is actually a use case that we have built with IKEA. Unfortunately not with an RGBD sensor, but with a single camera, but it already works pretty well. You should try it. It's part of their catalogs. So what are the tools that actually allow you to do that? If you are a programmer, the Mateo SDK is essentially your tool to enter the augmented reality world. It's the most advanced SDK. It has basically everything included that we have to offer. So what you just saw in these two demos, both of the tracking mechanisms are actually available. But this is really more for native developers. If you want to develop an app in Android or iOS, this is the right tool to go through. What I'm actually way more thrilled about is our authoring tool. And this is also the tool that was used to build the demo that I will show you in a minute. And this authoring tool, you can actually try it at our booth. We are out there in the exhibition area. It's a drag and drop interface. You don't need any programming skills, and you can basically build an augmented reality experience in no time. And this tool has kind of liberated the augmented reality side, and that's the reason why I'm so stoked about capture and compute, because it really liberates the asset side of things. And that is kind of the issue that we have faced, or that we are still facing, or our developer ecosystem is facing, is where do we get interesting and very good content from? Because as you all know, content creation is extremely expensive, certainly when it comes to 3D content. So this is, so we are very excited that these tools are actually being used now. 123D Catch, or the structured sensor, their LiDAR solutions. But essentially what is happening at the moment is that these tools are being made available to developers or even consumers, and they are easy to use, and they basically create a whole lot of content for very exciting augmented reality applications. And this is important because the content is king, as you all know, and it's extremely important for us and for our developers to have rich and exciting content. So we have covered the capture side. Then there is obviously the model preparation. Basically for augmented reality, what is happening is that we render content in real time. So while we are rendering the content, we are also tracking your position in the room, or towards the marker, or towards the known object, and that already takes a fair chunk of processing power. So model preparation is another very important point, and we basically played around with Memento quite a bit, which is a really cool tool to do that. And then there's the AR application side, and you've already seen the creator. That is basically what enables you to build exciting applications. There we go. So this is kind of the intro to the application that we looked into, and this is kind of interesting. So one of our head of marketing was reading on BBC that most of the exhibition pieces that museums like the Louvre, the Guggenheim, or the Smithsonian have are not even on display. And I mean, I knew that they're not all on display, but the numbers are mind-boggling. They only have 8%, somewhere between 2 and 5% of the exhibition pieces on display. All other pieces are stored away somewhere, and no one will probably ever see them. And this is a huge loss, in my opinion. We can literally bring these pieces to the classroom, as an example. And I went online and I looked a little bit around, and for Smithsonian, they have 137 million objects and specimens, and they only show 2%. Granted, 2% of 137 million is a huge number. But anyway, so how can we make this, I would almost call it a treasure, how can we make this accessible? And Smithsonian actually developed it, or uses laser scanning to digitize their exhibition pieces. It's called Smithsonian X3D, and it's actually online available, so everyone can go on the website, and you can even download the models. So we did that, and we also used some models from Memento. And I actually wanted to show a live presentation, but I decided not to. So you can, it's like the live stage issue, but you can try it in our booth. So I prepared a video that should actually start. I think you need to press play. There you go, sorry for that. So this is it's a very basic user interface, but we can see we have marker and slam, so you can either start from a known object or you can just place it in your room. And then you can, and this is, I think this is one of the examples that is used in Memento, but we basically used Memento and the creator to basically bring that into the real world. And if you just imagine, you could basically use the library, the rich library of objects that Smithsonian has available, and you can make that accessible for kids. You can basically make a museum out of every room, house. You can really make it an interactive experience. You can walk around it. It's pretty much like it's there. And this was kind of the idea of our presentation, to show you how these new capturing tools and asset optimization tools and the creator basically liberated the entire pipeline and allows everyone to develop rich and engaging experiences. And that was it. That was all I had to show.
Thank you. Thank you.